Okay, YouTube, this is my second video in my module on solving trig equations. In this video, what we're going to do is basically focus on solving trig equations that have only one type of trig function in them. And basically, they are pretty basic. The steps that are involved when solving using, or solving equations only having a single trig function are to basically isolate the function on one of the sides of the equation and then just solve for the variable. So, kind of like we did in our last video here where we just had all these trig functions isolated, and we said, okay, what would make this true? That's going to be our goal, to isolate the trig functions in this video. So taking a look at these three examples, this is really all they are here, just a couple of examples I want to run through with you, but we say solve the following equations for all solutions on the interval from 0 to 2 pi. So one thing I want to mention here is we only want the solutions within one full rotation of our unit circle here, okay? But also we want this in radians. We want our answers in radians here. So that being said, let's go ahead and take a look at this first equation now. Because we have a sine function here, what we want to do is we want to get it by itself. So the first thing we need to accomplish is basically we're just going to add root 3 to both sides. This is just an algebraic process that we're going through here. So we have root 3 here, and then essentially we'd have to divide both sides by 2. So what we end up with is this statement where the sine function is now isolated. And what I recognize is, yes, there exist angles for which we take the sine of them and we get root 3 over 2. So we'd say, well, what kind of a reference angle would we have to have if sine came out to be root 3 over 2? And so this is where it's very helpful to draw in your first quadrant on your unit circle. And that's really kind of what I meant to do here. So let's just say I could draw the whole unit circle here, but just the first quadrant, we could list it here. So we have 30, 45, and 60. My handwriting, sorry, is not the best on this guy here, but we'd say at least it'll help us with our reference angles. We'd say 2, 2, 2, 2, 2, 2, and then of course 1, root 2, root 3, and then 1, root 2, root 3. So with respect to solving this, we say, excuse me, what reference angle would we have to have if we took the sine of an angle here and we got root 3 over 2? And I recognize that it would have to happen at a pi thirds reference angle or a 60-degree reference angle. So what we're going to do is we're going to list that our angle here, before I get ahead of myself and list the answers, let's go ahead and sketch out what we would know. We have sine is positive, which would mean we'd have to be in either the first or the second quadrant. And we know we have a pi thirds reference angle. So we're just going to sketch in a couple of angles right here that both have a pi thirds reference angle. So we say pi thirds there and pi thirds here. The question really, though, is in standard position, what are these angles? So we'd say one of them obviously is pi thirds. The other one looks like it'd have to be 2 pi thirds worth of rotation here. So we'd say theta is pi thirds and 2 pi thirds. So really just get the trig function by itself and do what we need to do, which is what we did in the last video. So we'd say, looking at this one here, we got 3 secant theta plus 5 equals secant theta plus 1. I think the idea is because we want to isolate the trig function here, they're both secant, we could start by getting all of our secants on one side. So I think it makes more reasonable sense here to subtract a secant of theta from both sides. Bringing that over here basically is what we get. We say 2 secant of theta plus 5. This would have to be equal to the 1 that was left on the right side. So again, isolating our trig function, we'd say, well, subtracting 5. Suppose we would get a negative 4 on the right, so that it's true that 2 times the secant of our angle, let's try this again, secant of our angle here is equal to negative 4. Splitting both sides by 2 now to isolate our secant, we get that the secant of theta is equal to negative 2. And so it's got to be true that if we reciprocate both sides here, that we get negative 1/2 as our cosine value. So first things first, what kind of a reference angle did we have to have? And what quadrants would we have to be in? So we would say A, S, T, C. All students take calculus. We say if cosine is negative, then we cannot be in the fourth, nor can we be in the first quadrant. So we have to be in the second or the third. And we say what kind of a reference angle gives us a cosine value of 1/2? And so I could say, well, cosine's 1/2, also at pi thirds or 60 degrees. So what we're going to do is we're going to draw in a couple of angles here that have 60-degree or pi thirds reference angles. So here are our reference angles. We say each one is pi thirds, since we're doing this in radians. So in terms of standard position angles here, looks like we get pi thirds short of pi. That would be a theta value of 2 pi thirds, okay? And a pi thirds past pi, or 3 pi thirds there, would be 4 pi thirds. So here are two solutions here between 0 and 2 pi. So looking at our last equation here, looks like we want to get tangent by itself. So this means that we're going to do what we normally do. Just because we have a lot of substance on the right doesn't mean things won't happen for us. So we say, let's start by subtracting 1 from both sides. So we would get 2 times our tangent of our angle. This would have to be equal to root 3 plus 2 all over 2 minus 1. I'm going to write 1 over 1 because really what we want to do here, let me switch back over my pen tool. What we want to do is get a common denominator. And so rewriting this whole thing, we have 2 times the tangent of theta is equal to root 3 plus 2 all over 2 minus 2 over 2. And so the nice thing about having a common denominator is now we can combine the stuff on the top. And I don't know if anybody notices yet, but our 2's cancel out. So really we end up with this. So far we have 2 tangent of theta is equal to root 3 over 2. And if we divide both sides by 2 here, divide both sides by 2, which is really not what I planned on having done. As a matter of fact, now that I look at it, we say divide by 2. But we would get this, we'd say tangent of theta would be, let's see, root 3 over 2 times the reciprocal of 2 over 1, which is 1 over 2, and we should get root 3 over 4. So one thing I do want to mention here is this. Because this root 3 over 4 is not a tangent value that often appears on the outside of our unit circle. We have a tangent of a 45 is 1, tangent of a 30, anything with a 30-degree reference angle is root 3 over 3, tangent of a 60 is root 3, and then all of our quadrantals we either get 0 or undefined. But basically something like this here, in a future video we'll look at how we could use a calculator in order to solve for something like that. But the idea is still here. You want to isolate the trig function first and then go ahead and solve it using your basic knowledge of the unit circle. Cheers.